Hey, so in this lecture I want to talk about lambda expressions, which were available since C++11. A lambda is basically an anonymous or nameless function object. These are convenient to define at the location where it is invoked or passed as an argument to a function. They can be invoked in place following the definition by using the function call operator. I will introduce the basic lambda syntax, and then as we go along throughout the lecture I will introduce more things to you. The syntax is a bit weird. We have the brackets, and I'll talk about those in a bit more detail later. Those are basically the capture clause. And we can capture variables by reference or by value in that. We'll talk about that in a bit more detail later on in the lecture. Following that you have parentheses, which is basically a parameter list similar to what you have with a formal parameter list in a regular function declaration. Then we have the braces, which is the lambda body similar to a function body, so your statements will go in there. When you call or invoke the lambda, then of course you want to execute the statements that are within the lambda body, similar to what you would do with a function invocation. You want to invoke the statements that are within the body of the function definition. So that is the basic definition of a lambda. Now to invoke it, we have to use the function call operator, as we do with the regular function objects, function pointers, and of course with regular functions as well, we go and use the function call operator to invoke or call it. At the bottom of the slide I have a couple of examples. In the first statement we will invoke the lambda, which will print out hello human. You can see again I use the function call operator at the end, and in this statement with the semicolon. The lambda in the first statement does not accept any arguments, so we are simply going to invoke it, and it's going to do a console output hello human out to the console. The lambda in the final statement on the slide is actually going to return a value, and it's going to take in two arguments of type int. Okay, so it takes in two arguments we can see that defined in the parameter list. Then it's going to return x plus y, which are the parameters. So it's going to return the result of the addition operation of the parameters. We invoke the function again by using the function call operator, and we actually have to pass in arguments now. In the first pair of parentheses, so to the left, we define the parameter list, right? But the parentheses to the right represent the function call operator, and of course we have to specify the arguments within that. So we pass in 5 and 3. We can invoke it right here in place within the console output statement. So I know the syntax can be a bit weird, but lambdas can be useful, especially to pass them into functions that has as a formal parameter some function. Okay, that expects a function object or a function pointer or something like that, as we will see in upcoming lectures. Okay, a recap: a lambda can be invoked in place following the definition. A lambda can also accept arguments and return a value. The return type is going to be deduced based on what you actually return, so in this case we are returning an integer. The return type can also be explicitly defined. Let's say we want to return a float or a double instead of an integer, and I'll show you how to do that here in a second in a demonstration. And you can also use type reduction to assign the lambda a handle or an identifier. You can see we use the auto keyword followed by hello, okay, which is going to be the identifier for this lambda expression. Then we can invoke the lambda multiple times by using the hello identifier followed by the function call operator, of course. So in that way it will be similar to a regular function call or a function object invocation. Okay, back in Visual Studio, let's look at a simple example of a lambda expression. Have the brackets for the capture list followed by parentheses, wherein we typically specify the parameters, but for right now we'll leave those empty, so this lambda expression will not have any parameters. And within the body we actually want to do something. I'll do a simple console output statement, and we want to end this off with a semicolon. Again, this is considered a lambda expression, so we end that off with a semicolon, but there is one issue with this currently. If I try and build around that, it should work, but we won't get the expression that we would expect. We only get the end of program printed out. And that is because, how do we invoke something? Well, we use the function call operator, right? So to invoke this anonymous function, we have to use the function call operator like that, ending that off with a semicolon. Build it on once more, and now it will print out that string. We get hello, and then we get the end of program. Now let's say we want to do some arithmetic function such as addition or multiplication. For example, I'll write a typical function. Okay, so this addition function is going to return an integer x plus y, which are the parameters, both of type int. Now let's say we want to do something similar for a lambda. Then we can do something like this. Now let me go and do a couple of variables to pass in. So with this example, I'm invoking the addition function within a console output statement, and I'm passing in the variables a and b. Notice this part right here. We call the function, we have the function identifier, then we have the parentheses, and we pass in those arguments a and b. Now, of course, with the lambda expression, we have the braces, then we have the formal parameter list, then the body, so the definition of the actual functionality that we want the lambda function to have. Then we have the function call operator, where we want to invoke the function, we need to pass in the arguments. So instead of having a name to the left of the function call operator, as we do with addition here, we have the actual definition of the lambda expression. We can pass in those arguments like that. We can invoke this in a console output statement as we do with the addition function. And because this is contained within this statement right here, we do the single semicolon at the end. Okay, we don't add a semicolon over here, so don't get confused with that. You're in the statement off with the semicolon. And of course, these two printouts would give us the same thing now, but we have an unnamed or anonymous lambda expression or function right here. Build around that. We get that initial statement, and then we get 8 and 8 printed out for both the addition function invocation and the lambda expression as well. You might think this is a bit useless at the moment because we can use functions such as addition up here and so on, and also let's say we want to invoke the function multiple times. With a regular function we can do that, whereas with this unnamed function right now we can only invoke it once. But what we can do is, we can give the lambda a name or identifier. We can use auto for type deduction, and then I basically assign that lambda to that, so this hello identifier is now for this right here, that lambda. But of course we don't want to invoke it right here, so I'm going to remove the function call operator at the end of it. And then this is how we would actually invoke it. We specify the identifier, followed by the function call operator, and of course the semicolon. Build around that. And you see that works fine. We get hello human printed out as before. So let's go and do the same thing for this lambda down here. I'll cut that out. We already have the addition identifier, so I'll call this one sum. And as before, this is going to take in 2 arguments, and it's going to return x plus y. Now you can start to see a pattern here. This is the invocation of this regular addition function that we have defined up here. And then here we go and invoke the sum, which is this identifier, which is assigned to this lambda expression right here. We get hello printed out, followed by 8 and 8. And of course you can go and click on here, do Ctrl K and Ctrl I, and you'll see this will return void hello, and it has no formal parameters. Whereas the sum right here, Ctrl K, Ctrl I, is going to return int, and it takes in 2 arguments of type int as well. Now that we have handles for these lambdas, of course we can invoke them multiple times, as you can do with a regular function. So this addition function, for example, let me go and do something like that. And I'll just remove this hello lambda for now. So in a similar way, since we have a handle or an identifier for this lambda, we can invoke it multiple times. Build around that. The point is, now that we have a handle for the lambda, we can invoke it multiple times. Okay, I'll go and clean up. Now let's say I want to do something else like division. And I do something like 3 divided by 2. And build around that. We'll get something like 1 instead of 1.5. Now one thing we can do is we can go and convert one of those to float or double. Let's go and do double here. If we build around now, we should get 1.5. So it's going to deduce the type correctly based on what we return. We do not specify the return type to the left of the definition of a lambda, as we do with a regular function definition. There is a way to explicitly define the return type, but I'll talk about that a bit later here. What I want to do now is I will do something like this. I have an if statement. we return the double, but then here we are going to return an int. That is ambiguous, so we're going to get an error. I'll build that and you can see all return expressions must deduce the same type. Okay. And actually we need a semicolon over here as well, but we are still going to get that error. All return expressions must deduce the same type. Remember, with a regular function we can explicitly specify the return type, and we can do something similar with a lambda using the arrow operator. In the definition, following the first pair of parentheses, so following the parameter list, we do the arrow operator followed by the type that we want to return explicitly here. With an integral, you have to remember that you'll lose some data here. You can see the result is truncated. But that's fine, we can build a run now, we don't get any errors. This is just a demonstration, you won't do something like this. And as I also mentioned in the lesson on functions, it's best to stick to a single return statement. Then you will avoid this sort of thing. But I just wanted to show you that you can specify explicitly the return type that you want for the lambda. Okay, I've cleaned up the division lambda and we'll move on to a couple more examples now. Firstly, we can use auto here for the type in the parameter list. That is in C++14. If you do this, the compiler will generate the function call operator as a template, and in that way we can create more generic lambdas. For example, this division statement is going to return a double. I'll just remove the explicit return type right here. And actually I'll also remove the conversion, so I'll just do x divided by y, and I'll copy this line now. Now this will return an int because we're going to do integer division, we pass in two integers. But if we do something like 3.5, and I'll build a run now. The first printout you can see we get integer division. The second printout we get a double, or that is floating point division. Okay, so I just wanted to mention that you can have more generalized lambdas in this way by providing auto for the types in your parameter list. You can mix those as well, so I'll do int for the second parameter, build and run, and you see this will work fine still. I'd also like to note, if you do not specify parameters and you do not specify an explicit return type, then you can actually leave out the parentheses. For example, I'll do something like this. I have the brackets. Again, this is still a lambda, but I leave out the parentheses now because we are not specifying any parameters for this lambda. It's simply going to do a console output statement. Now we want to invoke this, so I have to specify the function call operator in the statement off with a semicolon, build around that, and you'll see that works fine, even though we do not have the parentheses. And before moving on, I'd like to reiterate the difference between calling or invoking the lambda. So currently here, we are not invoking the lambda, we are defining it. We are defining it and we're creating a handle for that. But let's say I want to invoke that right here, like that. I'll comment these lines out. And of course we'll get an error now. We need to specify the actual arguments here. I'll do 5 and 2 for example. Now this result is a variable, it is not the identifier for the lambda function. Okay, you can see it's actually going to be of type double in this case, because that is the type of division that we will do in the body. So let me build around that. You'll see we get floating point division, and we get that hello human printed out again. So again, notice the difference between calling or invoking the lambda and assigning the result of whatever it returns to a variable, which we're also automatically deducing the type for that. So again, just emphasizing the differences. And actually what I can do is, I'll copy that. Now you can see what I mean. Change that here to something like 5 and 2 as well as we have it here. But the point is, this is now an invocation of a lambda, and we assign the result. We pass in the arguments, we invoke the lambda, and we assign the result that we return to a variable, the type of which we automatically deduce. And then here we go and assign a handle or identifier to this lambda right here. Okay, this div for division, and then we can go and invoke it like this. And here I'm simply printing out again that result. So build around that, and you can see this will work fine here. So just emphasizing the difference between these two things here, invoking it and returning the result, and then defining it and assigning a handle to it.